coupling. What do you mean by mutual coupling here? Line number 1 is between 1 and 2. Line number 2 is between 1 and 3. They may be running side by side. So to some extent, there may be mutual coupling between them. If coupling is there, what do it matter? The voltage at the other end of the respect to 3 or 2 will be affected by the coupling of these two lines. That's called mutually coupled. So likewise, so many transmission sections may find mutual coupling with neighbor transmission line to cause a change in the voltages. If that is the situation, how would our Y bus matter? Yes, Y bus definitely gets affected because the equivalent inductance of the line get affected. You know that when two inductances are there in the side by side position, as long as there is no mutual coupling, they exist individually L1, L2. When there exists a mutual coupling between them as a M, then you will find a net equivalent inductance of them become definitely different because of coupling existing between them. In that case, if there exists a mutual coupling, how to calculate that is the next small modification in the same program. Can you see over here? This program tell you Y bus by singular transformation method with the mutual coupling. There is no change at all. The change is the one extra information given to you. What is given? Element number is given as usual. There are 5 elements. 1 to 2, 1 to 3, connectivity. Whatever is that, doesn't matter to us. Connectivity. Connected by impedance. This you must see carefully. Z1, Z2, Z3, Z4, Z5. Each line is given with a impedance. No matter in the current program, what you have done, data is given in the impedance or admittance. I am able to get YPRI. That has been done already by logic. Creating choice equal to 1, data is in impedance. Choice is other than 1, data is admittance. That we have just now worked out. No matter whether it is an impedance or admittance, we can do it. But look at this, it is impedance. These 3 columns represent my old problem type, variety. For that, I have to prepare A matrix, I have to prepare ZPRI, convert it to YPRI, obtain Y bus. That was the routine work I would have done only for these 3 columns. Take bus 1 as reference. It's said here. Now read the next column, mutual element. In this diagram, element number 1, blank, no coupling. Element number 2, no coupling. The element number 3 is between bus 2 to 3. Element number 3 is between bus 2 and 3. He is mutually coupled to element number 4. It means 3, 4 are coupled mutually. There is a coupling between 3 to 4 and 4 to 3. This is put as an information. So element number 3 and element number 4 are coupled mutually by J.1 impedance. Then 4 is coupled, 5 is as usual. So this extra information you need to take care. When it is 3 element is connected to 4, how our entry in the computer matter? Yes, there is a small change. That change is mutual coupling has to be acknowledged in the program. Then program runs as usual. To do that, again I have to draw graphical representation. 1 to 2, 1 to 3, 4 buses are there. You can see here 1, 2, 3, 4. However it is drawn, I have drawn it in a random way. 4 buses I have drawn. Then directions I have marked. 1 to 2. Can you see here? 1 to 2, 1 to 3, 2 to 3, 2 to 4, 3 to 4. However it is being read, left to right movement, I must consider the arrows. 1 to 2, left to right, 1 to 2. 1 to 3, left to right, 1 to 3. So I have marked the arrows here. Then each element is 1, 2, 3, 4, 5. The labels are given here. This becomes graphical representation of the problem. Then from this, which is said as a reference bus number 1. So bus number 1, you don't touch, don't look at the bus number 1. Look at the bus number 2, 3, 4. At 2, how many elements are connected? 1 is incoming, minus. 2 is not connected. 3 is outgoing, plus 1. 4 is outgoing, plus 1. So minus 1, 0 plus 1 plus 1. You can see here minus 1, 0 plus 1 plus 1 because 5 is not connected to me 0. In this regard, it has to go. And please make a note here between bus 3 and 4. This vertical arrow, arrow going from 3 towards 4 has to be numbered 5. Is it looking like a 4 here? In fact, it is a 5. It should be 5. It is looking like a 4 for you repeatedly. 4, 4. 2 times you will find here, but it is 5. 3 to 4. 3 to 4 is number 5. This has to be treated as 5. Okay. Therefore, I should connect this information in the form of a matrix called as A matrix. Reduce the incidence matrix element across nodes directly, leaving the bus number 1. Otherwise, what I have to do? I have to do extra. A cap I have to do, column number 1 I have to delete. You can do it, or you can reduce the work by using your knowledge. Once it is done, what is ZPRI? Earlier we did. ZPRI is a matrix or a YPRI is a matrix. The elements are positioned diagonally. Now be very, very careful. Is it in impedance or admittance? Impedance. Then your ZPRI you have to write. ZPRI equal to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Can you see here? Diagonally they are dumped. That's all. Very simple, but Z by notation. Later, what is the meaning of mutual coupling? 3 is coupled with 4. It means 3, 4. 3 cross 4 is J.1 and 4 cross 3. You can see here 2 non-zeros here. Diagonals are as usual elements of the problem. But there are 2 elements non-zero, J.1, J.1. These represent element 3 coupled with column number 4 element. 3, 4 is non-zero. 4, 3 is non-zero, which is mentioned in the problem. It means element 3 is coupled with 4 or 4 is coupled with 3 means bidirectional by a data J.1, which you have to position in the table. 3 cross 4, not 0. 4 cross 3, not 0. The content is from this table. So this becomes ZPRI of a problem where mutual coupling between element 3 and element 4 exists. There can be any number of mutual coupling. Then that many zeros will disappear. One mutual coupling will have 2 zeros disappearing. One more coupling comes, 2 more zeros disappear. Likewise, ZPRI matrix has to be prepared in that due regard. Therefore, once you have ZPRI, what is actually needed for me? YPRI. I have to invert it. So I am inverting. YPR equal to inverse ZPRI. So this inversion is not straightforward. You should learn how to invert using partial inversion or diagonalization or even Gauss-Jordan method. So one session I will initiate with the MATLAB how to do that inversion. So this inversion I could do directly in the MATLAB, put it and get the inversion. So invert it. Once you do it, directly equation A transpose YPR into A. Directly substitute, get the answer. There is no difference in the work. The only difference is recognition of mutual coupling. Once you recognize where to locate this representation in the ZPRI matrix, respective row by column position, this data has to be put. That's all. That's the only change. Rest all is as usual. So if that is the reason, that is the case, if I take you back, how that particular program will be different? The program will be different in a very simple manner, wherein I have a very simple change in the particular representation. Flowchart for singular with mutual coupling. If I want to show you, you just see start, read the data as usual, create A matrix, create ZPRI matrix, select and fix the reference, for loop, get the ZPRI data K, 4. It's absolutely same. Get it, repeat, and come. You will find here new thing. This was not there in the old flow chart. What is this? After having ZPRI matrix diagonally positioned, rest all are 0 obtained, Here you are touching specially ZPRI 3 comma 4 equal to 0.1 I, ZPRI 4 comma 3 equal to 0.1 I. What is the meaning of this one? Element 3 is coupled with the 4 is coupled with the 3 with the information 0.1 I. This you are entering into the ZPRI matrix to see to it that your calculations are pertaining to coupled case. One coupling will have two non-zeros. Once it is done, no doubt, rest all is same. Choice is 1 or 2, whatever you do it, it's same flowchart, Then same program must be there. When I have same flowchart, only one extra step is added here. Rest all is same. What must be the program then? Program also look very similar with two extra lines inserted. You will see here how is that program. I'll just go back and show you the programs of that also in this way. Lab manual. Okay. Very simple. Same program is used. I am in the main program, inspection method. Just now, without coupling, this was a program. If it is with the coupling, formation of Y bus using singular transformation method with mutual coupling. Can you see over here? A data choice K equal to K like this. Can you see these two lines extra? ZPRI 3 to 4 coupling, 4 to 3 coupling by information. Rest all is absolutely the same. No change. What is the change? Which element is coupled with the which with the information you have to enter. That's all. So therefore, in this way, if I work Y bus by singular transformation method by mutual coupling is also possible to do it. So if I go to the program window, now you look here, clear command, clear all, choice equal to 0. Let me make choice equal to 1 here again. Choice equal to 1, data of a problem, K equal to 1 to 5. It's readily available. Choice equal to 1. This one is. Now what is not available? Then what I will do? I will copy it. So I will make a copy of this. Control C. I will make another file just for the simplicity. Control V. Then at the end of this ZPRI, what I will do? I insert. What I will insert? I will insert a line ZPRI bracket 3 comma 4 equal to 0.1 I semicolon and ZPRI bracket 4 comma 3 equal to 0.1 I. Can you see here? This is the line which I wanted to do it. Okay. So what I did here, same program. What is the understanding of this one? This problem, I don't know what problem I have typed here, but I made a entry 3 comma 4, 4 comma 3 is mutually coupled. This is the only modification to the old program to convert it into coupled case. This data, no matter, I can work this like this also. Whatever the problem I have here, doesn't make any difference. It is 0.05, J.15. But here it is not looking like J.15, something else. It is the inversion of this one only. No matter. Whatever the data you have here as per the problem, as per your condition, you have executed it. Only thing is this you have to do. Let me show you. What I will do, I will make a comment, Control R. Okay, it is an old program. When these two won't run, it must be old program. I will save it. Save program. What is that title I have given? My test 3. My test 3. I just give. Okay. So without that, when I run it, it should run with error free. It should be running it. There is no doubt about it. Okay. Just give me output. I'll show you once more. Once more, I'll run it and show you in front of you. Okay. It's running. So choice equal to 1. If I make a choice equal to 0, it must run. Can you see? Changes are happening here. When I make 1, when I make 0, changes are happening. It is new program working for you. Now, when I use coupling case, these two lines I invoke. So Control T when I press, these are now active. When these are active, these answers won't be same. Size of the Y bus, no doubt 3 cross 3, but Y informations are different. Let's see. Can you see here? there are some elements whose values have just modified. Let me see here. So the answer of your hand calculation, which is the answer, I have modified it here. I'll show you 3.089 and this thing. Just let's see what 3.66. That answer. Okay. This answer. So I'll make it 1 first. Okay. 1 means data is in impedance form. You have to invert, then you have to use it. That's the meaning. Let us run it. So this data is inverted and some cells are modified and you are using the calculation. So this is the output of this particular program when I use information in the problem as impedance. When I make this information other than impedance, directly go, ready to go and execute it. So this data is considered as admittance and these data are used in the particular program. Now you might ask me, actually what is happening here? You are preparing it as impedance. You are considering this as an admittance. So there is a little shift in thinking. I'll come to the problem here. Suppose this data is said to be in the form of impedance. It is advisable to feel it as impedance. Impedance. Work is uniform. You can do it. By chance, this data is given in impedance and this is in admittance. How do you do it? Quite difficult. You have to convert it to one format. If this data is also admittance, mutual admittance is given, not the impedance, admittance is given. It's quite easy to convert. In this way, the notation of impedance, admittance, and other combinations you must see carefully and accordingly invoke in your program. Then you try to work it out. In that way, you have to establish the connection. So I could try with 0, which is an admittance directly. At that time, these two will be considered as admittance because I am setting it. ZPRI and this data I am dumping in the position, I am copy pasting the information. You might logically solve on the paper and you will see when I make it admittance, entire view is admittance. When I make it impedance, entire view is impedance. So this way this simple program is done. You can comprehend this whichever the conditions you can apply. Therefore, this exercise makes you little aware about how programming is used to do Y bus by inspection method, Y bus by singular method, Y bus by singular method with mutual coupling. No matter this data can be modified. Whatever the problem is there, accordingly you can modify. So this way, a MATLAB environment and number of programs, step by step, you can use into your work. So therefore, please go through all the lab material which is shared to you. They are useful to you by simple experiment by hand calculation, converting them to a flow chart, converting them to a program and making it executed on the command window. Likewise, you have to do. And apart from this, there are so many syntax errors you might encounter. No matter how many errors you get, that is the confidence level which you are going to get improved upon. So this way we have to work